I'm really excited to introduce you tonight to our guest speakers. I'm going to go ahead and introduce them in the order that they'll be speaking this evening. Our first speaker tonight will be Matt Frazier. Matt is an 18-year-old veteran of the pro audio industry with stints at Mackie, just down the road, and DPA. Matt has a broad perspective on the tools that shape and are shaped by audio engineers, performers, and audiences around the world. Prior to his work with manufacturers, he focused on his career as a musician while also earning a master's degree from Cal State Los Angeles. Matt lives in the Seattle area and holds the Pacific Northwest close to his heart. Thank you, Matt, for being here. Our subsequent speaker, Paul Andrews, is a global support specialist for DPA microphones and is the owner engineer of Foundation Sound Studios in Nashville. Paul has worked with industry leaders such as Al Schmidt, Bruce Swedien, Chuck Enley, and Elliot Shiner, and his recording credits include Chris Christopherson, Boys to Men, Victor Wooten, Dennis Chambers, Bill Evans, and the CSU Symphony Orchestra and Big Band. Paul attended Denver University on scholarship in classical guitar, then joined the staff at A&M Records, where he worked with Sheryl Crow, Aerosmith, Danzig, and others. Paul continues to record diverse styles of music from classical and jazz to punk. He also travels internationally, conducting workshops and live seminars for DPA microphones, educating industry professionals on microphone technologies and best practices. So without further ado, let's welcome Matt.
Thank you, and thank you for being here, and for everybody online too. It is amazing. I agree with Dan. It was incredible to see that lineup with deference to everyone who is online, and even those of you in the room who were possibly this will not apply to. For all of you who, like me, went to high school in the United States, I want to start with a little bit of a geography lesson to remind you where Denmark is, because I'm sure you once knew, like I did. Yes, sir. Moving? Is it moving? Technology, it makes our lives easier every single time. Yeah, okay. Camera was not made in Denmark, I'll tell you that much. This is the one and only question I'm going to ask you tonight. And by the way, my comments will be brief. Paul's the star of the show. I just want to give you a little bit of history of DPA because history is fun. So my one and only question for you or anybody online, anybody know where the name DPA came from? Old timers or just very clever young people? So originally it stood for Danish Pro Audio. It really doesn't stand for anything now. It's just DPA. But the reason I bring that up is because our identity as a Danish company is critical to who we are and what we do. With microphones, as in life, geography is often destiny. So when you look at this map, you see very small country, Denmark, sharing a border with Germany, right? What are the Germans known for? Well, I mean, the good things Germans are known for. Precision engineering, right? Really high-end expectations for electronics, for mechanical engineering, etc. The Danes have that in common with their neighbors. The other neighbor is basically Scandinavia. There's a bridge that, it's not on my map, but trust me, it exists. There's a bridge that connects Denmark to Sweden and the rest of Scandinavia. And what do we know about Scandinavians? Well, you go into any like mid-century modern furniture store, and it's all about design. It's all about form following function, elegance, etc. And that's who the Danes are. They like design, and they have very, very high standards for engineering. And that is what you will see, I think, in DPA products. I promise not to make this a commercial, but you know, sometimes I bubble over. Whoop, it's not the right way. Turns out in Denmark, there's quite a robust audio industry. There's a lot of infrastructure, a ton of brands that originated there. We even have representing in the room, a little B&O action, Bang & Olufsen, thank you. What this means is that there's a network. There's a network of people who are constantly thinking about audio hardware in particular, although also some software. And there's a lot of sharing of information between those companies. For example, the current CEO, this is just an anecdotal example, the current CEO of DPA was once the CEO of Bang & Olufsen, right? He was also once the CEO of Bruel Kjaer, which was mentioned earlier, and I'll talk about a little bit as well. So you see this sort of networking of audio professionals within Denmark. Okay, so Jim online queued this up for me earlier. Thank you. Quick history of DPA going back to the very founding. 1942, these two whippersnappers on the right side of your screen, they look younger then, graduated from the Danish Institute of Technology, where they had studied under the lunatic over on the left-hand side of your screen, who was just a sound nut. He was actually called the noise professor, is what his students referred to him as, because he was obsessed with measuring sound, understanding it, frequency, direction, everything that we know about sound. So these two guys, Bruel and Kjaer, they went off to make their fortune and have an impact on the world. And they did that. And they became, Bruel and Kjaer became the world leader in measuring sound, particularly in industrial contexts. So this here, not a microphone. It's a whole bunch of complicated machinery that measures vibration and other aspects of sound. B&K was so successful that if you needed something delivered overnight, they brought it in their own airplane. This has nothing to do with our presentation, but I love this airplane. And so I show it every chance I get. They had their own airplane. Are you getting the implications of this? People online, are you understanding? An airplane. Bruel and Kjaer grew and grew and grew until finally, in the early 80s, a clever one or two audio engineers from Danish public radio said, you know, we've heard about this company, Bruel and Kjaer, and they make all these devices to measure sound accurately. Wonder what it would sound like if we captured music for broadcast through one of those devices. Turns out it sounded amazing. And when I took this job 4 years ago, I would tell friends, I'm going to go ahead and say it, old timers in particular, I'm on the brink of being an old timer. I can live with it. I'd say, hey, do you remember those Bruel and Kjaer mics? And there's two words I always heard. Oh, yeah. They were really natural and really open. And that is true of those mics and of the DPA identity now. You will never hear someone talk about the color of a DPA microphone. You will never hear anyone talk about the pleasant distortion or warmth or anything like that from a DPA microphone. You will hear people talk about accuracy, about how little they need to EQ, etc. Okay, so in 1984, yes, 1982. It's really critical. I get the date right. I know, I can see it on your faces. In 1982, Bruel and Kjaer released their first ever pro audio product. So 40 years in business, thriving, never making a microphone to capture music or speech or anything like that. Introduced pro audio microphones, did it for 10 years. And how many of you raise a show of hands are old enough to have worked with B&K mics in a studio? Steve, yeah. Oh, nice. You defy your appearance. You seem so youthful. So for 10 years, Bruel and Kjaer made pro audio microphones. Turns out it's a really small industry compared to automotive and airplanes and all that stuff. So the company basically said, this is not worth our time, laid off the two main guys, sales and marketing and product design guys, who are associated with the pro audio products. And they said, well, we still believe in this. Okay with you if we just keep doing this? And they had kind of a handshake agreement. I'm like, yeah, sure, go ahead. What do we care? So to this day, B&K, Bruel and Kjaer, and DPA still have a strong relationship. There's still, it's nothing official. We're not owned by the same company or anything like that, but it's very friendly, and we work together on occasion. But this is what whoop, again, wrong button. This is what DPA looks like today. Founded in, incorporated in 92. So that makes us 30 something years old, 31. This is what the company looks like now. The factory is, you can't totally tell, but there are cows in the next field over. It's about an hour outside of Copenhagen. Inside, it's like the Willy Wonka of microphone land. Every day, 100 people, it's actually more now, show up and spend the whole day building microphones. Every DPA microphone is made in this environment. I don't know why, but it's almost exclusively women who are building these microphones. I asked why when I visited, and the answer I was given from the plant manager was because they're better at it. They hire guys and guys lose interest, whatever. So lots of precision, microphones being made by hand. You can see on the right-hand side here, these are back plates for our miniature microphones, one of which I'm using today. Each one of those in that Mylar is an actual backplate. And again, you can see just the high control environment that these mics are made in. DPA microphones pass through 30 sets of hands. We do have a couple robots now. I haven't updated this slide. So for the most meticulous work, we have some machines that are part of that. 200 more processes that go into every single microphone the DPA makes, rigorous testing, calibration, and so forth. The folks who are doing this, they are really intense about their jobs, and they're super proud. It's amazing for these people when they see, you know, Celine Dion on stage with the microphone that they built by hand there in that factory. We say made by hand, but it's made by hands. There's so many people involved. That's DPA. Paul is going to come and wow us. Wow, I say.
Wow.
See,
Oh my goodness.
already.
Matthew, thank you.
It's this big green button.
This is the big green button?
The little red one
Don't
goes
do
the
that
other
one.
direction.
Forwards and
Sorry about
backwards. Love it. Thank you everyone for, oh, we're gonna try and find the camera over here. Is it coming? It's coming over here. It's following me. That's fantastic. Yes. Hello, everyone. Thank you again for having us this evening. It's such a pleasure to be here, and we really appreciate the opportunity. I have a very meaningful quote by a gentleman by the name of Morton Lindberg. I'm going to pause for a moment and let everyone take that in and absorb it just for a moment. I highlighted at the very bottom in yellow, balancing engineer, and I want to keep that in our mind for a little bit later on in the presentation. We'll see if we can't bring that back up. And for anyone who doesn't know or isn't aware of who Morton Lindberg is, I highly suggest looking him up and his 2L audio. We'll learn a little bit more about some of his techniques here shortly. So, yep, green button, Matt, big one. You sure, Matt? Yeah. We're gonna try it one more time. No, doesn't go back, forward or backwards. Scared to move. I don't want the camera to stay where you're at. Oh no. Yep. Ta-da, there we go. Okay, fantastic. It is that technology thing. It does work. Yes. Yeah. Perspective and perception. Immersive audio, immersive capture, more specifically. When I start to look at and try and do some research into this specific topic, I'll type in things like how to record immersive audio. I see a lot of pictures of some fantastic control rooms, and I see a lot of speakers. That doesn't tell me how to record, right? I try and type in Atmos recording setup. Maybe that clues me in a little bit further. A lot of great pictures of, different control rooms. I love the one over here at Blackbird, oh, there's another Blackbird one. It's like, okay, where do I go from there? Immersive recording setup. This is a struggle. Where am I going with this? Well, the simple fact is that at least in my limited time in this world and in the immersive world more specifically, it's fairly difficult to find information on how to actually capture audio immersively. So I started to think about this. I started to take myself down a path of what I would normally do in regards to how do I set up a session? How do I think about, if I were to step back, how do I serve the song? How do I serve the production? Let's follow that path a little bit. What is our ultimate intent? Who is it intended for? This is going to hopefully start to take us down the road of our approach and how we ultimately capture audio immersively. Contemporary. Let's label this as, for now, popular music intended for post-consumption or potentially live playback. These are all going to be just ideas, things that are going to feed us a little bit and hopefully get our brains going. I do encourage questions. I do encourage being interrupted. Let's go down some bunny trails and let's dive into this a little bit, okay? So let's consider the contemporary aspect of it. Neat thing about this is we have the opportunity to literally create something from nothing. We'll dive into that a little bit more. Classically based. Okay, this may be a different approach, right? Perceptually, we have the opportunity to then create an existing space for post-consumption. Or maybe even live playback. What could that look like? We could recreate a concert hall. We could recreate the conductor's position. We could become a member in the choir. Starts you thinking down the road of positionally. Where is our end user? That end user who's sitting on their couch, not able to attend the show or the concert, didn't get the tickets, but yet having the opportunity to experience it to its full extent in their living room. Kind of a neat thought. We have broadcast, sporting events, live concerts, just a few examples. I know that there are many, many more, subsequent topics that we could list under this one. Film, documentaries. So this is hopefully just going to get our brains thinking a little bit about all of the potential that we have in regards to how we ultimately deliver this product. Who is it intended for? Motion capture, another one, right? Okay. With that, now that we've potentially determined, okay, our audience is going to be this person or this group of people. Now we can start to think about the actual recording approach. What does that look like? So I've broken that down in a few different categories as well. Let's talk about single source recording. So when you think about contemporary, you think about popular music for the most part, something that's going to be, whether it be a top 40 or whether it be something that is radio playable, something that's going to be consumed by potentially younger artists, however you want to categorize that, right? Here's where we have the opportunity to potentially create something from nothing. And in my experience, close miking, having the opportunity to basically have the control to get rid of whether that be secondary sound sources, reflections, and or multi-microphone recording techniques will give you the opportunity to then steer or potentially place these different sources in a much more clear fashion that's understandable and digestible to the end user, so that we have the opportunity to then place these sources, you know, whether that be up in the left hand region or whatever that looks like. Now you have control over these to the point that you're not going to be fighting whether it be that reflection or whether it be that stereo recording that you've created, because now you're not necessarily going to have to work with the secondary sound source. And how does that move with it, right? Some of the tools that I like to use in regards to the close miking setup. You'll see several, obviously, these are DPA microphones, but I just wanted to highlight a few of them. The 4055, which is up in this upper left-hand corner here, that being what we like to call our kick drum microphone. It's in what we call an open cardioid pattern, obviously designed originally to work in and around low content or low frequency content sources like kick drums. It works fantastic on bass cabinets or on horns, different things like that. The neat thing about it is it's low sensitivity. So even though it's in an open cardioid fashion, it's designed to be close to the source. So what that ultimately means is that you are going to maintain that level of control because it's that close to the source. So you're not going to be getting those secondary reflections to the greater extent. The other really neat thing that I really like about DPA in general, and hopefully this doesn't turn into the sales pitch, but I'm super excited and always have been with the both on and off axis frequency response. So when you think about that, accuracy in both on and off axis, what does that ultimately mean to you? Well, to me, what it means is that even though I will potentially introduce or have a secondary sound source, whether that be a reflection or a different instrument at any given point, and you know, if you don't have the opportunity to record things in complete isolation, that off-axis linearity is going to be accurate enough that then you also have the capability to work with it rather than work against it. So in traditional frame of thinking, let's picture a drum set. Drum set as an ensemble or drum set as individual instruments, right? If we think about the drum set, you are ultimately going to have potentially anywhere from 1 to 12 microphones or however many you want to get crazy with on that. With that in mind, you're going to have secondary sound sources that are coming in through all these different microphones. You will get bleed from the snare into the tom and into obviously your overheads and so forth, right? Doesn't it make better sense to have on and off axis linearity as opposed to something that you don't quite understand in regards to what's happening off axis here? I don't quite get that. This is when you have potential phase incoherencies. So now you start having to fight against the bleed rather than having the capability then to work with it, right? So the 4055, the 2012s, the green button, Matt, pushes things forward, right? Okay. There's another green button on here that does a cool little laser thing, which I like to do too, which is cool. The 2012s, we recently introduced these. These are also designed primarily for close proximity. These are in a standard cardioid position. Really great little tiny pencil condenser microphones that I just love putting on absolutely everything from snare tops to guitar cabinets to basically anything with a speaker at that point. I love it on Leslie's, you name it. Really, really great microphones. The 4018A right here, supercardioid in pattern, utilizing our A preamp, which is a transformerless design. The reason I like this one is obviously because of that pattern. This allows me to really have the opportunity, especially in environments where you will have that secondary sound source. This will reject that very, very well with that tighter polar pattern, which is nice. The 4099s up in the upper right-hand corner, a lot of people refer to these as our instrument mics, which is very applicable. We build a lot of different attachments and mounts and things like that so that you can mount it to an acoustic guitar or the drums or a cello or horns. The neat thing about these is that they do have a 7.9-inch linear operating distance, meaning that it is also designed to be very, very close to the source, which is neat. So supercardioid in pattern again, ultimate in rejection of everything else except what you're pointing it at. I can say the same thing about the de facto, our handheld vocal microphone, utilizing yet again supercardioid pattern, 160 dB SPL handling capability. Neat thing about that one is it has a 60-degree window. So even if the vocalist is on and off axis with that, there's a nice 60-degree window that allows that microphone to work flawlessly until you step outside of that window. And then the null point really starts to hit at that point. And that's where the rejection really comes in. So I've done recordings with this microphone, you know, piano player, singer sitting at the piano, playing, rejecting a grand piano that's right there and primarily focusing on their voice. So it does an excellent job that way. And last but not least on this page here, the 4018 ER. This is a really neat setup that I've come to love. It encompasses a lot of the same attributes as the 4099 series, but what it allows you to do is take our larger capsules like the 4018, 4011, 4006, any of those larger capsules, and utilize that on what we call an active cable. That active cable then has the opportunity to be mounted, as you can see in the picture here, to an adjustable gooseneck, which then allows you to utilize any of the 4099 mounts so that you can mount our larger capsule on that upright bass or the cello or the horn or the guitar or whatever the instrument happens to be. So now you've got a little bit of flexibility in regards to not only price point, but you also have in terms of overall sound quality as well. You can step it up. You can go from the 4099 series, which are fantastic, but then you can also take that up to the next level with our larger diaphragms. Questions or anything on anything we've covered so far? Anything from the online community out there? Not yet? Great, okay. I am. Yeah, okay, great. Yeah, Do you hear all of that squeaking? It's the water bottles being handed out. I'm not doing that.
Hey, if I could, I could make
Squeaky
a
shoes? Yes. Thank you, Carrie. Appreciate it. I'm waiting for the pictures, buddy. Yes, yes,
quick comment.
yes.
I have had tremendous results. In fact, probably the most commented on kick drum that I ever recorded was done with a 4011 inside the drums. And similarly, probably the most complimented I got on a whole drum set was once when I mounted a 4007 Omni immediately over the rim of the bass drum on the beater side and used it to capture the whole kit. And even though you guys are great about now designing stuff for applications, boy, would I encourage everybody to really, these microphones are so linear, you can use them in a lot of ways that you wouldn't imagine when you look at the thing.
That's absolutely fantastic. Thank you for sharing that. Yeah, I agree with you. I love the 4011 on, well, there's nothing I actually don't love it on. Yeah, I've also placed it in and out of the kick, and it's great. The 4007 you mentioned, I am so sad that we don't produce that anymore, but you're right. And in that case, and we'll talk about it a little bit more, but whether that be the 4006 or the 4041 at that point.
The 4006 is basically the same mic with lower self noise, and you probably don't need the 168 dB threshold before capsule distortion that the 4007 had.
Right. Yes, yes. You have a question? Yes.
It's just a clarifying question.
Yeah.
What do you mean by linear?
Oh,
I don't.
no, that's
quite.
fantastic. Thank you. Thank you so much. So linear, when you think about the frequency response of a microphone and you've got all the way from the bass all the way up to the high end, the treble end. So a lot of times you'll see that represented as from 20 hertz to 20K kind of a thing. Okay, so when you're looking at that on, say, a frequency response chart, the microphone's characteristics and how it ultimately picks up sound will be represented by a curve oftentimes. And on that curve, the flatter that line is, it's going to be more linear in that sense. So when I talk about the on and off axis linearity of the microphone, it's one thing to be able to brag about the on axis linearity of a microphone. You know, oftentimes microphones are tested at the factory or before they're released in anechoic chambers, and they go through this process. And unfortunately, there are no true standards on how these tests are actually conducted. But you'll see oftentimes manufacturers will say, okay, we are completely linear and flat, you know, when we're on axis like this. And that's great, and that's wonderful. But what happens when you start to get off axis to the source, whether that be 30, 60, 90, 180 degrees off axis that way? So that's what I was mentioning earlier in regards to the on and off axis part. So when you are off axis, you are 60 degrees off axis. You want that line to be just as flat as the on axis line, right? So that these lines remain parallel with each other to the greater extent. When they don't, and they start crossing each other, when you have, say, your 30-degree off-axis line cross with, say, your 60-degree off-axis line, that's when you start to enter into problems, frequency-specific problems, and that may be an omni effect that takes place specifically at that frequency, that type of a thing. Hopefully that didn't want to dive in too deep, but just to make sure. Great. Yes.
think another aspect of linearity is the IO transfer function. In other words, is everything that's quiet at X dB, the things that are louder are even in a linear proportion to that too.
Absolutely.
And I've used like the 4007 and even the 4955 from Bruel Kjaer, and they are very linear, both in the frequency domain and the level domain too.
That's great. Yes. Thank you for bringing that up. Good comment. Next slide I have up. So moving away from our close to the source single mono microphone techniques for the greater extent, moving into multi-microphone, or what I would call close array. Here we have a very nice, I'm going to call it a coincident, pair of microphones. This is what we call the 4560. This is something that you actually wear. So it's a binaural set of microphones that work very much in the same way as the headset that I'm wearing. It comprises of two of our Omni microphones, our 4060s, I believe, and they touch right inside your eardrum right here. You don't push them in, but they just sit right inside the ear right here. The neat thing about this is that they basically look like earbuds when you're wearing them, so you can be very covert with it if you want to do, or be recording. But at the same time, the unique footprint that happens with this, and it took me a while to kind of understand and experience this to the greater extent, but we're all uniquely shaped. We're individuals. And the neat thing about that is our ears are also super individual. So what I like about this microphone is it steps away from the binaural head microphones that we've all seen, and those are fantastic, because we as individuals have unique ear shapes. We are creating a unique footprint that can only be reproduced or be produced by the individual wearing it. I kind of like that thought. So when you wear this microphone, it's paying attention to the unique shape of your ear. It's paying attention to the density of your head. It's paying attention to the shadowing, to the size and everything of your features, whether you have a large or a small nose, a big forehead, all of those types of unique characters that we all have. It pays attention to all that because it's going to be capturing sound differently on me than it is on anyone else. And that is a very, very fun and unique aspect to this microphone. So I had this thought. I'm gonna veer off topic just for 2 seconds. If anyone ever wants to do a study on this, I would be super curious. We all have realized and recognized music over the years that has become standards that we've listened to. They're audio examples. They're excellent examples of recorded music that has stood the test of time, and we've heard it a million times when people do, when they tune systems or whatever that happens to be, right? Over and over again, we hear these songs. Well, I would be super curious if we could go back and find similarities in the engineers' ear shapes that have potentially recorded these tunes and see if there is something that actually lines up and says, we understand why this is such a good song, why it sounds so amazing, because this person's ear shape is similar to this person's ear shape, or there are, enough similarities that way. I know it's totally off topic, but I was like, I've got to geek out on this for a second. It's so fun. Okay. So the 4560, right? We then move into, oh, you have a question? Please, go ahead.
Awesome. Yeah, so if we're talking about the idea of these kind of unique like localization patterns that come from the actual shape of the user weighing the 4560.
Yep.
I kind of see two branches of use here, which is on one hand, we try to find, maybe we're in a video game or something like that, right? And we're trying to find someone that looks like the main character to wear the actual microphone, right? Put the main character in the actual body of the user.
Okay.
But on the other side of it, you're looking at like the biggest accessibility. So maybe it's like a basic UI, like, oh, I'm going to log on to whatever Siri type thing with my earbuds on. And maybe listening to localization that is too different from my own creates a negative user response. Do you think that with this type of technology, we're heading towards a more like unique recording that puts us in a specific spot, or are we kind of taking a average, what works okay for everybody? Or do you think it kind of goes both ways? That's just what came up to me when I look at this.
No, that's great thought process there. I honestly think it's a little of both. I do think that standards need to be created. There are companies out there that utilize different pieces of equipment and microphones like this to create profiles, and whether those profiles are then generated for the unique user or individual, or whether those profiles are then accumulating a standard that will work for a lot of people.
Yeah, and if we have looking way off in the future, right? But if there's some like tiny little mini version of these that just comes like, say, with actual earbuds that you have, right? You could have sort of like have a bunch of different recordings of UI or something like that, right?
Mhm.
And then the user, there's some little setup thing where it just actually records audio in a similar way to this, and it can perhaps kind of match up the different localizations and kind of pick out which one might be closest to what the user would actually hear just from their actual head by wearing the earbuds or something like that.
That's a really neat thought.
Yeah.
Absolutely.
Cool. Thank you.
Thank you. So this next picture I have is at the Ryman Theater in Nashville. Up in the upper left-hand corner, you see what we call the 5100 surround microphone employed here. And what it's ultimately doing in this particular scenario is we're using it to capture the crowd, the audience, for the most part. There are microphones that are down on stage and around much closer to the audience that are also supplementing in this recording. But the neat thing about this microphone is its unique characteristics. If we take a look at this a little bit closer, it honestly looks like a big, comfortable bicycle seat. I often use it as a travel pillow when I fly. It has 5 microphones on the inside of this pillow. So you've got your center, your left, and your right, and then you have 2 rears. So originally designed for 5.1, but we're going to move beyond that very quickly. This branches out with a single LEMO connector to 6 XLRs. Those 6 XLRs will obviously represent each one of these channels. The 2 rear microphones are also summed to create your 0.1. Okay, so there you've got the 6 XLRs that branch out very uniquely that way. It's positioned, the microphones are positioned, everything is phase coherent. It's a very easy deployable, very quick coincidence set of microphones that you can set, boom, whether it's a permanent install, whether it's camera mountable, all those options are there. But the thing that I started to think about, if we take a look at the top of the microphone, On the top side, you can see the mounting bracket, or where you would potentially put it on the microphone stand or mount it to the camera. Well, there's one of those on the bottom side too. So what does this ultimately give us opportunity to do? Well, stack them. So now I have the opportunity to take a 5.1 microphone, put a separating bar in between it, and put a second one on top of that. And that height can determine. I can determine whatever that height needs to be. It can be directly on top. I can have one facing forward and one facing backwards. Or I can separate them by 3 feet from each other. Depends on the environment. It depends on ultimately the production. Where do we want to go with this? Where do we want to put the end user, right? We have opportunities here in a very quick deployable fashion, right? Moving on to spaced arrays. But before I do this, any questions on some of our what I would call coincident setups? Anyone online? Anything? No? Okay. Spaced arrays. So you can see we're going from the mono source. We're starting to branch. Oh. What do we have? Jim, yes.
Sorry for the late hand raise.
No worries. No.
What are the dimensions of that microphone pack as it sits? Yes, of the 5100.
The dimensions of it, or like the overall size of the microphone?
Overall size of the package.
Yeah, that's a great question. I don't have the absolute specifics to, but I can give you an overall, like a general idea. It's about this big. So the width is designed to basically mimic about the size of the human head in that regard. It's in a pie shape, so it's kind of a triangle fashion. I'm gonna guess it's about that big total, and it's maybe 2.5, 3 inches thick. Yeah.
Thank you very much.
Thank you. Oh, thank you, Matt. $240 by 140 by 195 in millimeters. There you go. Thank you. 0.9. Thanks, Matt, for looking that up. So it's about this big. Yeah.
Thank you for that.
Yeah, you betcha. Okay, spaced arrays. This is where we start to have a little bit of fun. Not that we haven't had fun yet. Spaced arrays. The S5 surround Decatree DPA produces. This is also a product that has been out for several years. This is one of my favorite toys. This is something that I deploy as often as I possibly can. This is a very configurable tree that allows for many different types of configurations. What we have here is the opportunity, obviously, to house 5 different microphones at varying distances. It will recreate everything from the standard Deca, if we only wanted to use 3 microphones, up to, I believe, 8 or 9 of the very established different type of arrays that have been dreamt up all over the world at this point. So it's very flexible in that regard. We'll walk through just some of them. The neat thing about this is you can see in the photos here that it comes in sections. All of these sections are obviously predetermined with the varying lengths. So you have short or half extensions as well as the full extension capabilities. What you're looking at the very ends where the microphones are mounted is a telescoping type of mechanism where you actually have the capability to slide that out and back in, so you can get that last little bit of measurement, and that is marked for you so that you can make sure that you have the exact same extension length on all sides, and it remains 100% phase coherent at that point. This is a huge time saver in the sense that when we look at some of these arrays that people are putting in studios, or they're flying above orchestras and things like that, you'll oftentimes see these arrays where they'll take and spend hours and hours, with laser measurements, and they've got 15 microphone stands on the floor, and they're all fighting for the real estate space to try and set that up. And then they're measuring from this microphone to this microphone and this over to here, and they're constantly adjusting and trying to build these arrays, when this one will basically, you can walk in and you can set up 5 microphones in about 10 minutes, and that it's all going to be placed properly, which is really neat. I'll show you some other configurations here. And these are just examples. These are, like I mentioned before, these are some of the established configurations that people have come up with all over the world at this point. This is one of my favorites here. This is touching upon a little bit of the Hamasaki square technique, which is really fantastic, especially when you start thinking about height in your immersive capture. This is also one of my favorites here. It not only utilizes a lot of the same concept from what we would call the Hamasaki square, but also it's incorporating a little bit of a standard deca you can see in this configuration right here. Back to Morton Lindberg.
One quick question.
Oh, yes.
Right here.
Oh, there you are. Sorry.
Hey, I had a question about the one that you're describing as the Hamasaki square.
let's go
That's
back.
not a configuration I'm familiar with, but is that 4 mics instead of 5?
It is. It is just utilizing the 4 in that particular scenario. Yep.
And so was that associated with quadraphonic approaches, or where did that?
You could absolutely use it in that sense. So, and that's a great segue into a little bit of more depth in terms of the spaced array. When you think about ultimately, where do we want to go when we think about spaced arrays, and how do we consider microphone placement, and what do we want to capture in the first place, right? All of the different approaches that we kind of went through earlier on in the presentation, whether that be contemporary or classically based, it all depends on, like I mentioned before, ultimately, where do we want to put the listener? Who is it intended for? And so when we start moving into spaced arrays like this, now you have the opportunity to start capturing larger spaces, right? And obviously we want that space to be acoustically beautiful, whether it be that concert hall or that recording studio or whatever that space is that we want to try and put the end user back into, right? So with that being said, a very simple yet logical approach is you take a look at the system that we saw so many pictures in the beginning of all of these beautiful mixed rooms, right? And we're like, wait a minute, I have 3 speakers here, I have speakers here, I have speakers here, I have speakers here, I have speakers here. why not represent that with microphones? Keep it really simple. So when you are capturing that space, kind of takes guesswork out of a lot of it. You're like, well, I designed this microphone's position to represent this area. And so in this sense, this is covering a lot of what you would commonly see in some of these mix rooms that have your height channels available to them, right? So that's kind of where I go with that. Great question. Thank you. So here we have a wonderful array that Morton Lindberg with 2L has developed over time. This is an array that is quite extensive, and it utilizes in this particular case, and this isn't just why I love Morton, but it's all DPA mics, which is kind of cool. So what he's utilizing here are 100% Omni microphones in this particular scenario. It's kind of hard to count, but you can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there's 11, 12, 13, 14 here. He's using a variety of our Omni microphones, which we'll jump into in just a moment. We'll dive into those specifics a little bit more. This is a very common scenario for Morton, and one thing that I've at least observed in the research that I've been able to do, and I'm sure that some of you out there online have probably much more experience with this in regards to what happens actually on the floor with Morton's recordings. But for the most part, this is what I see him doing 100% for the capture. So this tree that he's devised here is basically extended up above the players. And so he's not doing any close miking that I'm aware of. This configuration, it's rather difficult to see. I'll try and spell it out a little bit here for you. This is a fun project that I had opportunity to work on at Ocean Way Studios, Nashville. And what I've basically done is I've taken 2 of our S5s, those Decas, and I've started to utilize the Lego parts, and I've put 2 of them together at this point. So what we're looking at here is the first S5 is sitting here. So I have it ultimately extended on 2 stands. So keep in mind that this is 100% configurable. We have the opportunity to shrink it, to expand it, to raise it higher, to bring it lower. So we have 1, 2, 3 microphones here, 4, 5, 6, 7, 8, 9, and 10. In this configuration, we are utilizing all directional microphones. They're all the 4011As, so that's a standard cardioid. That was the engineer's choice to capture the ensemble or the orchestra below and the room. There's another picture. I'm not sure if it shows it any better, but it might at least give you a little bit of a different perspective of that. I think we had that at about 12 feet in height. Maybe we pushed it up to 14 just to grab a little bit more height out of those. Now, this configuration is really neat in the sense that obviously what I touched on a minute ago in regards to whether they're directional microphones or whether they're omnidirectional microphones like Morton is using, there's a lot of flexibility in that. And how much of the space are you looking to capture in regards to direct sound as opposed to just the reflections coming off of the walls, that type of thing. The other thing that I started to think about this configuration is this is really neat in the sense of, okay, we've got our ensemble around it. But what happens if we were to take this and focus inward with it? What happens if we've got these two stands right here that are holding it up, and in the center on the floor, we put our solo artist? What if there's a solo cellist or a solo piano player or something, that this is now sitting in the center of this, and now all of these microphones, this array, can either be focused inward or outward, depending on what we're looking for. But this would give us the opportunity to utilize something like this in a very high quality solo recording situation in a space where who would have the opportunity to sit in the cellist's seat and actually listen to it as if they are the player in the room. Kind of a neat thought. Some of the microphones that are used are the ones that I prefer to use in these various situations. Starting at the top, our 4041, which I mentioned a little bit earlier. This is one of Morton's favorites as well. This is an Omni configuration. This is one of, well, it is the largest diaphragm that DPA currently makes at 24 millimeters. It is proprietary unto itself. It is modular like a lot of our other 4000 series microphones, but we currently only build it in the standard 48 volt version of that. So really neat thing about this microphone is its noise floor is riding in and around 8 dB. So super sensitive, about 70 millivolts. So super hot as well. So this is a highly sensitive microphone, picks up a lot of amazing detail. The second one, the 4006A, we made reference to a little bit earlier. I'll come back to the 4006 because it's got some really fun toys and accessories that we can utilize to shape the sound a little bit further. Our 4011A, which one of our attendees loves to put on the inside of a kick drum, and so do I, which is awesome. So that's a standard cardioid. When I say A, when you have the A after the capsule type being the number, so it's a 4011 or a 4006, that A is making reference to the preamp type or the body. Okay, so that's that longer body section after the capsule itself. And then last but not least, the 4015A being our wide cardioid. Yes.
There was a question online from Marcus Buick. The slides before this showed various arrays.
Yeah.
Why did B&K and DPA veer away from the classic tetrahedral array of the A and B format ambisonic recording solution used by Michael Gerzon and the Soundfield folks? Why did you veer away from that array?
That's a fantastic question. I am going to guess because it was probably a small enough market that it was difficult to continue and justify. Yeah, I don't have the inside information on that, but that would be my most logical guess in that regard. That's something that we could maybe find out from Denmark, but I'm not even sure that they have folks that are aware of that at this point either. Good question, though. Okay, so back to our 4006s. The 4006 Omni, the one that started it all, the one that Matt mentioned earlier, or maybe he didn't mention, but he did talk about that one B&K microphone that started it all when we recorded the Danish Symphony Orchestra. This 4006 Omni was the microphone that accomplished that. And the neat thing about this is we build some really fun accessories. The ones that we're looking at here, we call acoustic pressure equalizers, commonly referred to as 8 balls. No laughing out there. Nobody. 30, 40, and 50 millimeters in size. And what these ultimately end up doing is they will slide over the capsule portion of the microphone and allow just that front grill of the 4006. I'll back up so we can see that a little bit right here. Just that silver portion, just that grill itself will be exposed on the outside of this hole right here. And so ultimately what this does is it gives us the opportunity, depending on the size, so the smallest is going to have the least effect as opposed to the largest, the 50 millimeter will have the greatest effect. But what it ultimately has the capability of doing is directing the higher frequencies. So the mid highs all the way into the highs, what it'll ultimately do is it starts to, I'm going to say, focus that polar pattern and starts to tighten it in a little bit. So when you think about an Omni microphone, obviously being 360 degrees, it's picking up everything, right? When you start to focus those mids and highs and you start to tighten that pattern in just a little bit, the microphone maintains its full frequency response as an Omni should, which is fantastic. But now you have a little bit of steerability. Now you can start to pull things in and actually create a little bit more, I would call it, definition or potential direction. So in a standard configuration like the Deca, where you'll have, say, 3 of these, left, center, and right, you utilize, say, the 50 millimeter balls. Now what you're doing is you're taking those mid and high frequencies and focusing them in so that when you're back at the console and you're panning things hard left and right, you're getting a greater sense of separation, even though these are still Omni microphones, which is really, really neat. The 50 millimeter 8 balls here are my favorite. They will mimic the exact frequency response and polar pattern shaping, I would call it, of the original M50s. So as we know, the M50s are what the original Deca was utilized with. And so the neat thing about this is we can capture a lot of that vintage potential nature in regards to the way the M50s would pick up and handle those high frequencies and how it would squeeze that pattern in just a little bit. But we have the then capability of the DPA and the higher level of detail and the clarity and so forth. So there's those nice differences that you can compare and contrast. So the acoustic pressure equalizers, fantastic. The next one, just to let you know that thinking about that S5 Deca, we offer these in matched sets. So oftentimes you'll just see them in groups of 2, but obviously here we'll do them in groups of 5 as well. And that doesn't matter whether it's the 4006s or 4011s or 4015s. We can offer it in complete match sets as well, which is pretty fun. That wasn't me, by the way. Moving on to a few different types of spaced arrays here. This is a very unique approach. Many microphones. I'm not even going to begin to count, but one of the thought processes in this regard, which is actually quite entertaining, and I love the thought of, is you can see everything is paired up. I believe every microphone here is a 4006 all the way around behind. You've got the 2 height channels. You've got these mids, everything like this. When they're paired up like this in this A-B fashion, oftentimes the thought process, and I haven't had opportunity to have this verified, but when you're thinking about sitting in the control room and you've got your speaker array around you, no matter what that configuration is, standard configuration, you're going to look at left and right here. But then this speaker and this speaker, now I can look at left and right here. And then this can be left and right and left and right. And around those, all of those various variables, depending on how many speakers you have. So in this sense, it really allows a lot of control in that sense, in that manner, that you can have stereo imaging happening between your different objects or your bases or however that comes. So just another approach. This is also a really neat approach in the sense of putting that end user in the player's position.
So I have a basic question for a basic understanding or
Yes.
disambiguation here. So these spaced arrays, you have all of these microphones, and of course, you know, because I haven't done this before, immediately it comes to mind, it's like you've got phase issues, just like coming out every pore that you've had in your body. So is the idea that these spaced arrays, then the signal from each either mic or each pair of mics will then be in a mixing environment that has a corresponding number of speakers? You mentioned Atmos. If you could maybe elaborate a little bit on what's the translation from here, the recording, to at the beginning of your presentation, you showed all these pictures of the mixing rooms, which was all on the, you know, the loudspeaker end of things. And now you're focusing on the mics, but maybe you could clarify how those two things work.
That's excellent. Yes. And you were spot on with that. So the way I like to think about it, and to keep it simple, is if I have the opportunity to place microphones in a fashion that I will ultimately end up pointing or placing them in my sound field when I mix, to keep it simple that way. Now, in terms of phase coherencies and making sure all of that is lined out, that's where things like the S5 come into play for me, where they really start to simplify it, or the 5100 being that tight coincident pattern where everything is set, and I don't have to manipulate or work with several different microphone stands and lasers and trying to get the measurements of all of that to come out. So in another way you could think about it is, let's say you've got your mix environment. You understand where you want to put the listener at the end of the day. Let's say the control room that you're working in, you understand the dimensions between each of the speakers. You understand the height of the room, you understand the dimensions of the room, and where all of those speakers are placed. Why wouldn't you want to potentially take those measurements and shrink it down into whether it be a spaced array or whether it be a coincident array, right? So if you take those measurements and ultimately just bring it in, why wouldn't you be able to expand it back out when it comes to playback? Because everything will be accurately represented at that point. I hope that kind of moves down the path of, yeah. Good question.
We've got an online comment.
Wonderful.
From Rod. Rod, do you want to unmute or ask it, or?
Yeah, you mentioned the diffraction spheres a little bit ago. My experience with the M50/TLM50/M150 and KM133, which are all omnidirectional microphones, and you know from whom. The axis of flattest response is about 60 degrees off the direct axis of the microphone, and so it's got a flat response not just in one place, but on the edge of a cone all the way around the central axis, or 0 degrees axis of the microphone. And I find it's nice to set instruments along that axis or position the microphone so that that axis is directed more at the near field, the instruments closer to the microphone. And of course, the instruments farther away because of the air loss and the pitch up on the direct axis of the high frequencies, that tends to compensate that in another way, so that those microphones are usually directed to the back of the sound stage when I use them.
That's a fantastic comment. Yes, I 100% agree with that. That's being able to utilize the characteristics of the microphone to its best advantage there. That
I mean, one thing I would add to that is that it's as though you're equalizing the back of the microphone slightly different than the backstage of the performing space differently than the instruments in the near stage, and you've done that with one microphone.
Exactly.
So
really neat. I'm going to touch on that a little bit more in just a minute. I think I've got 2 slides to go, and then we'll dive into that a little bit deeper. So far, the spaced arrays that we've looked at for the most part have been in an omni configuration as far as the microphones being utilized. I just wanted to show you a Hoon-Kook Lee reference who came up with the idea here. I'll try and explain this a little bit further. The red polar patterns that you see would be the lower, and the blue would be the higher. If I remember right, it's covered up. It's written up there at the top. Maybe I don't want to move the camera. Never mind. But you can kind of see the different positions, the 90-degree position, and then obviously utilizing a few of the different polar patterns. So here you're using supercardioids. Here you're at the front and the back, you're using 2 standards, which would be this setup right here, 130 degrees on 2 cardioids on your left and right sides like that as well. So that just gives you a quick idea in and around one of the successful scenarios that has been developed over time, and move on to the next slide here. Oh, there we go. So what does Al Schmidt have to do with immersive capture? As we know, Al Schmidt passed away a few years ago and didn't have a whole lot to do with immersive capture whatsoever. I had a wonderful opportunity to spend time with him, enough time with him that he banged it into my brain, several of the wonderful techniques that he's developed over the years. And this goes on and touches a little bit about what we were just talking about with the online viewer, and that is positioning of the microphones. It steps back to 101, right? We need to understand and think about what we're looking at in the room and considering all of those variables when we position a microphone. And it doesn't matter whether that microphone is going to be super close proximity to the source, whether it's going to be spaced away in a small or condensed coincident fashion, or whether that's going to be in a large spaced array, right? So one thing that I absolutely love, and this is also touching upon the comment earlier, is that the ability, especially with the 4006s and the different, acoustic pressure equalizers, the different grids that we offer for it, it really gives us the flexibility to manipulate, and exactly the way you had just described earlier, in the sense that you can literally start to EQ and focus things in an acoustic sense rather than in an electronic sense. And that's one thing that I absolutely love about this company DPA, and why I'm so passionate about it is because when you start working at this level and understanding what is possible in terms of the absolute clarity and pristine nature that you can capture things that honestly the last thing you want to do is grab for an EQ, because at that point you're starting to manipulate things. You're potentially shifting phase. When you're shifting phase and you're doing things like that and you're having it potentially move around the room, what is that doing then, right? So when you start to think about how do I keep things first and foremost, at least in my mind, as simple as I possibly can, but then also maintain absolute audio purity, I start to think about, well, all of the things that Al Schmidt taught me. And that is, how do you position the microphone? Don't just set it somewhere and walk back and expect to fix it at the console or in post. Let's try and get it right the first time. This position here, this plot here, is also coming from Morton Lindberg, and this is just one example. So this is to the extent that I think, especially in these spaced arrays, we should start thinking about. And that is, okay, we've got this big massive array that we're either going to hang from the ceiling or we're going to set it up on stands at whatever height it needs to be at, right? Why not position the players appropriately around it? So as we talked about earlier, the microphone positions representing potential areas that we want to focus on, right? That's one aspect of it. But then let's take it a step further and let's put the players that are going to be captured with those various microphones in those appropriate places. So now you can take an ensemble such as this. This is not your standard configuration that you would see, you know, in any typical, whether it be performance or recording scenario, but it's 100% applicable in the sense that now I have my violin section being focused by these microphones over here. I have my second violins being focused over here. My violas all the way around. So when you start to think about that, now you take it even a step further and you're like, well, what about the mixing aspect of it? Back to Al Schmidt, back to 101, understanding what we're doing in terms of how we position not only the microphones, the players on the floor, and now the level of the players on the floor. So what does it mean? It means that we've got these three players right here. We monitor it back. They're too loud. What do? We push them back. Let's push them back a couple feet. What if they're too bright? We do exactly what we just learned about. We take some of these microphones right here, and if they were primarily on axis, now we start to take them a little bit off axis. And now it's going to start to take that high end and it's going to focus it out further. And we're going to have the opportunity to then lower that level to the greater extent of these folks here and gain a higher level of focus for the back row. So you're literally mixing on the floor and on the fly in a physical sense. So by the time you make it back to the control room and you position your sources where you want them, what are you? You're a balancing engineer. And that's where this comes full circle. So understanding how and why and what the ultimate purpose is of the production is paramount. It's key to everything. Because if you have the opportunity to record immersively, that's a pretty special opportunity in itself. So let's set it up so that we have ultimate success. I don't want to walk into the control room and sit down and hear all types of different issues and problems and phasing this and that I then need to correct, right? It's the same thing as having the opportunity to mix creatively and not correctively. And that's ultimately where we want to go, because that's where we're going to find success. There are many, many mixes, immersive mixes that are living out there with us today of existing catalog that didn't necessarily have this in mind. And granted, I didn't do that either. I don't know what that was. It might be the clicker. Might be, maybe not. Anyways, good thought. Totally just lost my train of thought right there. Thank you. You're always getting my back. I love that. So the mixes that are currently out there, you know, they may not have had the direction. Understanding that immersive audio, you know, hit at a very interesting time in and around, you know, a couple of hurdles, COVID and things like that coming at it, you know, the push to get content out almost to an uncontrollable extent. And the idea in and around, well, everybody's talking about immersive mixing and what does that ultimately look like, and who's thinking about immersive capture. And now it's starting to come, and that's fantastic. It's really exciting in that world, and there's a lot more to come. These are just some ideas that hopefully spark the interest to a greater extent and start us moving down that road in order to find success and to bring in and maintain the idea of absolute audio excellence when it comes to immersive capture, so that this medium ultimately blooms and becomes an absolute standard and is 100% consumable by everybody who happens to be either sitting at their laptop or on the couch, right? You have a question?
Yeah. So this is really, really cool. My one question in terms of immersive capture is, since as you're saying, this is such a new frontier, such a creative thing that you're doing on the fly, you're probably learning new things every time you do it with a new group of instrumentalists. How do we account for things like limited time in the recording session, or, you know, we're working with actual live instrumentalists who have to keep playing the thing over and over again before we can even hit record? So I'm curious about, you know, ways to compensate that on the performer side, and also maybe not making shortcuts, but, you know, the more you do it, I'm sure there's quicker setups to maybe take things into account ahead of time before the performers even show up.
Right, absolutely. I think that a lot of that steps back to the pre-production aspect of a project. The more communication you can have with everyone involved, you know, all the way from the money and the financing side, all the way down to the musicians and to the producer or lack thereof, whatever that budget or lack of budget looks like, the more communication I think that you can have ahead of time, so there is an understanding. The site visits that you could potentially go to, take a look at the venue or the space that you're going to be recording it in, develop what I would call a stage plot or something like that. You know, when you understand what musicians and what the instruments are, just the more that you can set up on that side of life, I think will really start to take you further. The ideas in and around whether you're using primarily the close miking techniques or any of the other ones that we talked about, all the way to the spaced arrays like this, talking to the client and understanding where do they want to go with it, and what is it ultimately going to be used for. If it's something that is going to be consumed, to the extent that you have opportunity to do something like this in a spaced array, or does it need to be condensed? Is it nothing more than providing the height channels in a crowd capture of a concert or something like that, right? So I know that doesn't exactly, answer everything specifically, but these are the types of steps that I would take in order to best prepare for the production.
That's awesome. I think the pre-production aspect of it makes a lot of sense. Just as you're saying that, I had one kind of other thought, which is, we can work perfectly with capture, right? But if we're working with live performers, the quality of the performance is also going to vary. So at what point do we say, okay, like maybe maybe I'm the mixing engineer and I'm like, this is a better capture, but someone looking on the more creative aspect of it says, okay, the capture wasn't as good, but the feeling of this performance was better than that one.
Mm-hmm.
I'm kind of thinking about kind of this compromise between immersive capture and immersive mixing, because if you plan everything best you can, but adjustments still have to be made, and the solo violinist shows up, blows it out of the park the first time, and that energy isn't there for the rest of it, you kind of have to make some tough calls, I think.
Agreed. Yeah, there's always going to be compromise. In fact, I've never been involved with a recording project where there hasn't. Yeah.
Thanks.
Great comments. Thank you.
Paul,
Yes.
we have a chat comment from a Dan Mortensen.
Oh, wonderful.
Looking back at that slide where you had the pairs of mics around the percussionist.
Yes.
He says, it seems that you're specifying both the microphone placement and quantity and the speaker placement and quantity. How does that translate into 1 million different listener speaker locations and quantities?
Not sure I understand the question. Do you mind repeating it?
Yeah, I think Dan will step up to the mic and rephrase that.
Right.
Yeah, sorry, I'm sitting at the farthest spot from this microphone in
No
the
worries.
room. So you're capturing sound through these many microphones, and you talked about how the simplest way to reproduce it is to have a speaker where every microphone is.
Mm-hmm.
So how does that seems like it's going to work perfect when you set it up that way, but I don't have that speaker set up in my house, and I doubt that anybody else in the world does it. So Atmos, so you're mixing all of these into Atmos, which does that for you.
Ultimately, no matter what platform you ultimately will end up on, yes, that is the ultimate goal, because you're right. At the end of the day, not everyone is going to have the opportunity to listen back in the most optimum environment, which would be, an immersive control room, right? With those capabilities. So what does it end up on? Earbuds, right? So with that in mind, whether it be, working with Atmos or any of the other formats, that is their ultimate goal, is that it translates as accurately as possible. Yeah.
So all of them translate that. And do you tell them how you want these various stems or sources to go to smaller numbers of speakers or larger numbers of speakers?
Yeah, so there are and I can't speak specifically into the behind the workings of how this happens, but they absolutely have that capability. So it's scalable in a sense, so that even though your speaker configuration may be different from the next person's, the translation will and should be the same.
And this allows you to translate all the way up and out. But
Yes.
You couldn't if you have like 5 mics, then you go up and it doesn't actually.
And for those online, Steve is saying that translates up and out
Yeah,
as compared.
this is sort of
Come
like
and
that
come and
thing.
talk, so nobody could hear that.
Well, this is sort of an optimal situation. You were talking about the other things where you have 5 speakers, 5 microphones as compared to however many are here. And but what this allows for is that once you get into those areas with more speakers, then it will continue to unfold instead of being, 5 sources that are spread across the speakers that are there. Not that anyone would really have it except maybe in a theatrical situation or in one of those control rooms. But that would be a reason to do this at all.
Absolutely.
Is it can unfold farther than less.
Yeah, thanks.
Thank you both. Thank you both. Let's move forward. Let's just touch very briefly on immersive playback, say in the live world. This has been something that I've been super fascinated with recently. And this happens to be at the Resort World Theater in Las Vegas, working with the front of house engineer Brad Divins on Enrique Iglesias concert. This was really fun. So this Resort World, I don't know if any of you have had opportunity to attend a show or not here, but it is in a very purposefully designed auditorium for immersive playback. They utilize a speaker company by the name of L Acoustics, and their immersive system is called Elisa. And ultimately what it allows you to do is to take what's happening on stage and immediately mix that into an immersive aspect for the audience. Now, you can get very, very carried away with this, and you can literally make people sick by throwing things around the room, disorient them a little bit, which is not fun. But you can also do it very, very tastefully. And so thinking about the type of capture that would happen in a scenario like this, clearly this is going to be as many mono close miking sources as you can get away with, so that you can maintain ultimate control of that. But then taking that back a step, and it's like, okay, what if this show was also going to potentially be broadcast or recorded for later consumption, somebody wanting to watch it at home? Now you have the opportunity to do like we touched upon earlier, and that is capture the crowd as well. So in a scenario like that, you have the opportunity to utilize things like the 5100 and put that up in its space, and have the opportunity to then grab all of the height channels so that you can place the person who's sitting at home on their couch, and they can feel the height of that ceiling in the crowd and the way that the sound develops throughout that space, which is really neat. So just to kind of give you some further thoughts in how the immersive capture world can be utilized. We probably all have learned very, very recently about the Sphere, also in Las Vegas. This is a little bit of a different type of a technology that is a lot of fun. In the same way, in terms of the capture aspect of it, everything that's happening up on stage, we're probably going to want to try and capture only the source, with the various microphones that we have placed. But also, they're utilizing a technology, I believe, by a German company called Holoplot, and they're utilizing what's called beam technology with their speakers, which is really neat. So at the end of the day, the sweet spot or the best seat in the house is every seat in the house. And they have the capability to specifically focus in on each one of these seats in a total immersive aspect. So not only visually, but also audibly, which is super fascinating as well.
And each of the seats are made to be like human flesh. So it doesn't matter how many people are in the thing or not.
Exactly.
It's pretty bizarre.
Yeah. There was a lot of like, ooh, that's kind of didn't expect that reaction. I can't confirm this either, but I think that they may have a haptic sense to the seats as well. Yeah. So that's really neat. So there is yet another opportunity for immersive capture, right? Being able to utilize microphones that basically go down to the DC level, right? You know, and grab that 5 to 15 hertz that's going to rumble your seat, you know, as they're showing the helicopter, or you're sitting on the motorcycle or whatever that is that you're visually watching, you can actually feel it as well. Kind of neat. Yeah. This last picture that I wanted to show you, I guess I think we're coming very close to the end here. This is at the Schermerhorn, also in Nashville. This is a project that I'm currently working on that the organization is wanting to go and have all of their pre-recorded concerts and shows that take place there to have immersive deliverables within that. So here's a nice combination of not only utilizing close microphones on the sources as you would typically expect across the floor here, but then up top, you've got one of the S5 configurations. Looks more like that one right there. That's currently about 27 feet up off the stage and is primarily there to focus on, obviously, the reflections coming off of the ceiling and so forth. So you can see how the microphones are all pointed upwards. These are 4011s, so they're designed to basically reject everything below it. And we wanted to just capture those reflections coming off of the walls and the ceiling up there to give them that height sense. That's going to be one of the neat aspects that they're going to offer, hopefully come first of the year. It just keeps going. Just more ideas in and around immersive capture. Sporting events, right? The 5100 yet again, you can see it positioned here, facing in towards the audience, down on the field, so you can capture the action of what's happening down there as well. And then obviously documentaries in different aspects that way. So when you think about immersive capture and where it ultimately is going, I think that there really isn't an industry out there that can't utilize it in regards to how and what we're doing with it. I think we're just starting to scrape the surface of it. Some people have found some amazing success within it already, which is wonderful, and they're leading the way, which I absolutely love. But these pioneers utilizing them in very unique situations. This is one of my favorites, actually. So the 5100, I think this was down in South America, actually, with a hummingbird feeder on top of it. My next step, because I have a lot of hummingbirds in my backyard, is I'm going to take this and I'm going to stack 2 of them. So I'm going to get not only my base layer, but I'm also going to get my height channels with these birds. That'll be a lot of fun. Any final questions in regards to anything we've talked about this evening? It is to a very huge extent, yes. And we build this, so this has got the weatherproof sock, I guess you would call it, housed on this. We also build a big furry dead cat that you can wrap over it as well. So if you're out in any type of windy situations, so it's applicable that way. Kind of a fun story in and around this mic too. I was on a shoot down in Mexico City before COVID, and forgive me, it was in South America, and it was on set, and they were utilizing it almost in a boom fashion. Car explodes. This is on set, obviously. Car explodes. They want to capture all of the sound, the flames, everything that's going on. Well, the boom operator got it a little bit too close to the action and the heat, and the front of that microphone catches on fire and starts to like melt. And he takes it and he bangs it on the ground to put the fire out on the microphone. And it worked, it was like smoking and stuff like that. And testing it later on, it's all melted and kind of gross in the front. Everything still worked. I was like, yes. Yeah. That is an industrial recording. We did not cover immersive industrial recordings. That'll be for the next topic. I love that. Yes. Everyone, thank you so much. Oh, you have a question? Oh, he's asking. Yeah, he's asking if we made the Mars mic. Yes, we did make the Mars mic. It is the 4006. So it's that Omni capsule that we were talking about earlier. That is housed on one of our active cables, which makes the entire microphone about this big, which is fantastic. That then goes to one of our products that we no longer produce called the MMA-A, which is a recording interface unit. It's 2 microphone preamps, analog to digital conversion directly into your iPhone or any USB device. So when the folks at NASA and JPL, housed their iPhone onto the rover, I'm just joking. When they housed their computer in there, they utilized 100% DPA in terms of the signal path in order to capture those recordings. So everything you've heard back from NASA at this point has been via DPA, which is a really proud moment for us. Yeah. Got a QR code with my contact information. If you didn't want to write it down, please feel free to contact me at any time. I absolutely love geeking out on any and all things audio and microphone related. Just don't call me in the middle of the night. Or you could, but I may not pick up. Yeah. Any further questions or comments? Anyone online? Everyone, thank you so much. Thank you, Don. Appreciate it.
All right. Yeah. Thank you, Paul and Matt. That was wonderful. And Greg for putting this together. So people online, we'll leave it open for a while. I'll set up some breakout rooms so you can chat in small groups. And come have some cookies too. Yeah, have cookies of your own. And then you'll be right in the spirit here. So Greg, where are we going to be? The cookies? In there. Okay. Okay. So hang out and talk for a while, everybody, and thanks for coming.